Let's solve this problem. Diana is playing a game with two dice. One die has M sides labeled 1, 2, 3 to M. The other side has N sides labeled 1, 2, 3, and then to N. So there's a range which is from 1 to N for the for die, I'll say B, and then 1 to M for die A. Write a program to determine how many ways she can roll a dice to get the sum of 10. For example, when the first die has 6 sides and the second die has 8 sides, there are 5 ways to get the sum of 10. 2 plus 8, 10. 3 plus 7. Ooh, so there's a lot of combinations that we have to do. Okay. Okay, and it goes up to 1,000. So it's 1 to 1,000 is this number of sides you can have. Okay. And so for the output, you just put, there's one way to get the sum of 10, so you just have to put the amount here. 6 and 8. Remember to put your, make sure to remember your periods. 12 to 14, there's 4 ways. Okay. Okay. Alright, so let me go ahead and do this. This was from another problem, so don't mind all this garbage. Well, not garbage, but whatever. Okay, so it's gonna be 06. This is J2. Roll the dice. Roll the dice. So I'm gonna give them proper names. So I'm gonna say die underscore A underscore sides, which is going to be the input for the number of sides from die A, and then die B sides. Same thing. Now what we want to do is we want to figure out the combination of these two. So for that, there are multiple ways that we can do this. So let me just try to write this out on paper and see what we can do from there. So we have, let's start off with something simple. Let's say like 6. So we have 1, 2, 3, 4, 5, 6 for let's say die A, and then you have 1, 2, 3, 4, 5, 6, 7, let's say 8 for die B. So what we need to do is we need to figure out how many combinations there would be in total, or we need a way to add all these combinations together. So this it does count for the different ways. So so maybe we can start off with the for loop to figure out the different ways we can do this. I'm thinking like there are, well, in this case, let's use something more simple. Let's use 1, 2, 3 for A, and let's use 1, 2, 3, 4. So you just multiply these two's length, so it's 3 times 4, which gives you 12. And there are 12 possible combinations here, because you have 1 times 1, you have 1 times 2, you have 1 times 3, right? Then you have 2 times 1, 2 times 2, 2 times 3, and then you have 3 times 1, 3 times 2, 3 times 3, and then you have 4 times 1, 4 times 2, 4 times 3. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Okay, so maybe we can start off by multiplying. So 4 underscore in range die 1 times die. So now what we can do is we can now, this is gonna run, let's say 12 times, so we can just go through each for A first. So what we'd have to do is for A in die underscore 8 sides, for B in die underscore sides, if A plus B equal 10, and then we'll have a counter here which we will count for. So let me just print this out for now. Print the counter. We're not done yet. I just want to see what we have so far. By the way, this video is not explaining at all. This is, I'm actually challenging myself right now. So yeah, let's do 6 and 8. 6, 8. Int object is not iterable. Alright, it's not iterable, so we'll use a string over here, and then a string over here, and then here we'll put it back into an integer because we want to mathematically add it up. Okay, let's try this now. So, oops, that was not what I had in mind. Okay, so it's giving me 0 when there's 5 ways. So maybe now what I can do is do for B, and then go and check. Well, when I'm doing this, do I need to put it in here? I have no clue. Let's see. Maybe we don't need to put this in here. Oh wait, what am I doing? Yeah, it's supposed to be 4, yeah, like that. And then it's gonna be 4 die underscore B in range 1, like that. And then we're gonna say, there we go, it's gonna be like that. Let's see if we have a numerical value now. Yeah, there we go. Okay. Let me see if this works for 12 and 14. It should. Yeah. All right. Perfect. We got it. Now, okay, I'm gonna explain why this works in a second, by illustrating it. But before we do that, I just want to say here, if counter equals 0, there's a different way of writing it. So it's going to be print, and let me just get the value here. So there is 0, there's 1. So if it equals 1, there's one way to get sum, right? Otherwise, print, and then here we're gonna have to use the F. So there is a counter ways to get the sum 10, and we don't need this print statement. So 12, 14. Okay, let me just submit the solution. Just make sure that my logic actually works, and then I will kind of explain it. Okay, it doesn't work. Oh, my bad. It does work. It's just I misspelled it. Hate when that happens. Okay. There is or there are. Probably there are, right? Oh my god, this is a disaster. Okay, there are. Sorry, the logic I think is good. It's just that I'm not printing the proper statement. So we need to be very, very careful about that. There we go. Perfect. You can see everything's correct. Okay, let me explain why this works. And you know, I don't know what I was doing from before, but over here what it's doing is these two are not actual ranges. I don't know, I started tweaking out, but these two are actually not ranges, they're actually sides. All right, so basically these two make up a range. So for example, let's say if we put for die A sides, like if we put 12, we're actually gonna assume that there's a range from 1 to 12 inclusive. So that's gonna be 1, 2, 3, 4, 5, 6, up until 12, right? Pretty solid stuff. Okay, so that's what we're modeling over here. Okay, essentially we're saying here, if there is a range through the range from 1 to the die A sides plus 1, because the die A sides is actually not inclusive in this range, so we want to make sure that it's inclusive, right? So if we add 1, then the 12 counts and the 13 is not included, right? In the case if I were to input 12. The same logic applies here. Then what we do is, once we have this, right? So now we have the ranges. Okay, so now it's gonna run in here. This die A value is gonna run for every number in that specific range of die A, and then all we're saying is then we're gonna run a sub what do you call it? Like a sub range, right? Or a sub for loop, I guess. And in that, all we're saying is that let's find the ranges for die B, right? And again, same logic here. So let's say die B is 1 to 5, right? So it'd be 1 to 6 over here, because the 6 is not inclusive, so it's really 1 to 5 values. And then all we're doing is we're checking based on these, right? We're just doing if die A plus die B equals 10. And then if it does, then we're gonna add that to 1, right? So if I actually print out the different values that we're checking, this is how it would look like. Hold on. Die underscore A plus die underscore B. And now let me just do let's do something simple. Let's do 3 and 3. So you can see here it's checking for 1, 2, 3, then 2, 3, 1, and then 3. You can see that it's checking for every specific combination of addition, right? Just by doing this simple trick over here. And how is it doing it? Well, if we do it manually, we have 1, 2, 3. These are being ran over here, right? In here. So essentially what's happening now is you have 1, 2, 3. So what is happening is you're running a sub loop in the actual parent loop, right? So let's say we have the value 1, right? So you're gonna take that 1 and then you're gonna run another loop on top of that, which is this logic here, right? In which we're gonna check for the die B. So in this case, the die B is also 3, so we're gonna run 1, 2, 3 again. Now we're gonna check for each of these values, because you can see here we're checking for each of these values, and that's where we're that's where we're actually printing this out. So over here it's going to check for 1 plus 1, then 1 plus 2, then 1 plus 3. Then it's going to move back to the original, the parent loop, which is here, and then go to the next number, which is 2 in this case. Then it's going to go ahead and run another sub loop of 1, 2, 3, because that's the range for die B in this case. And so now you're gonna have 2 plus 1, where it's gonna check. That's this, by the way, this logic here. 2 plus 1, 2 plus 2, and then 2 plus 3. And the same thing keeps happening for all the values. So essentially, in each of these iterations, we're just running another nested loop, you could say, in which we're checking for all of the die B values for that specific die A range or value. All right, so that's why this works properly. So it's really just this is it. If you get this, you're good. And then here all I'm doing is I'm just saying if the counter equals 1, then it's gonna be not plural, right? If you notice here, way is not plural, and also it's using is, not are, right? So essentially this means that's not plural, so we're actually reflecting that. Otherwise it's going to be plural, like there are 0, even though 0 is not plural necessarily. You use the there are and then the y with the s, so we're just using that print statement here. So that's what that does over there. So now I just explained everything, even though I wasn't planning on to, but I was kind of like going, like just doing it without explaining anything. So, you know, I just thought I might do it. So yeah, let's try this again. So 3, 3. It's going to say 0, obviously, because in the range of 3 for both, there's no way that you can get 0. But if I put like 3 and like put 10, there's going to be ways, right? Like 3 ways. And if we actually look here, let me actually do this again. So 3, 10. So if we look here, you can see that these are the specific ways, right? So if you look here, 3 plus 7, sorry, I should put this outside of the if statement so we get all of them. My bad. That tripped me out too. Okay, there you go. So these are all the possible combinations. You can see there's a lot of combinations. But if you saw from here, these are the specific ones that actually add up to 10, because if you look in our if statement, we're checking for that over here through this comparison operator, right? And we should put this in brackets just because my teacher likes it that way. Okay, perfect. So that is me. I hope that explanation was kind of clear enough. I'm gonna add comments which will be more clear because I like to write stuff down, but yeah, that'll make it much more clear. So over here, 2006, and this is going to be dice roll.py, and then git add dot git commit am git push u origin head. It's not gonna work because I need a pull. Okay, now it should work. Perfect. And so now if I look in my repository here, as you see 2006, and in there you have my code, which I'll now start commenting.